This message is brought to you by Spirion. The data privacy revolution is the new age of protecting what matters most. Automatically and persistently discover and classify sensitive data with the most accurate solution on the planet. Understand the data within the context of your business and then take actions to control that data so you can operate with minimal friction and comply with the laws and regulations built to protect the personal data privacy of individuals across the globe. This is Spirion, protecting what matters most. Visit them on the web at securityweekly.com/Spirion. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. Welcome back, everyone, to Paul's Security Weekly. Attend the RSA conference this year, February 24th through the 28th. Visit securityweekly.com/RSAC 2020. You can sponsor an interview with us or participate in a live broadcast as part of a sponsored interview of a number of our shows that we will be producing, recording, and streaming live from the event. Our listeners save $150 off if you go to securityweekly.com/RSAC 2020. John Loucaides is the VP of Research and Development at Eclipseium, the industry's leading firmware protection platform. John has an extensive history in hardware and firmware threats from experiences at Intel and the United States government. John, welcome to the program.
Thank you for having me. Great to be here.
It's nice to have you on the show here live. And I want to first start by, John, how did you get your start in information security?
Thanks. Yeah. When I first left college, I didn't really think that I was going to get into security right off the bat. But I sort of took a leap and tried, and U.S. government sort of got me this whole set of experience that I probably never would have had. And, one of the things that I found there was that there were these systems that you could spend millions of dollars on just doing all sorts of crazy stuff that normal people don't do. And you'd still have a way to break them with some simple little thing that happens to invalidate all the assumptions and everything comes crashing down.
Yeah.
So
that's interesting. Did you have a background in computer science when you started?
I did, yeah.
Okay. And so what drew you to firmware? Was that your mission, or was that was your own kind of curiosity?
It started really with my own curiosity. I really was interested in all of these things that bypass all of those really interesting, really expensive security protections that you might put into stuff. And firmware and hardware attacks do that. So I naturally kind of gravitated into it.
Now, when we traditionally speak of hardware and specifically firmware attacks, oftentimes we're talking about IoT devices, or back when Larry and I were heavy into it, it was embedded systems. These were independent systems, primarily the routers that people use to gain access to the internet and other such devices like cameras and whatnot. But now your focus is the embedded systems inside of other systems. What are the differences between the two? There really aren't too many differences, right?
Yeah, that's correct. I actually started the same as you, where the team that I was on, we even called it embedded systems at the time. And what I found was, computers are computers. They work the same way, whether you're, some small device with limited RAM, and the same sort of attacks are the ones that you're going to use in this embedded system versus this IT server. And that's actually one of the things that Eclipseium is sort of digging into, because you're finding that every device is really made up of dozens of these little components that are kind of the same thing as your embedded system that you're traditionally thinking about.
And these systems, John, that are inside, we can essentially call these small computers with an operating system, right? Like they have their own, in other words, they have their, if I remember like some of my first textbooks that were describing what a computer is, right? It had a bootloader, it has a kernel, it has operating systems, and it has a file system. These are inside of our basically computers today.
Piles of libraries, all with old libraries that probably have a bunch of CVEs associated with them, and then multiply that times however many different components that are inside that box, whether it's a laptop or a server. Same idea, and that's actually what we dig into. That's what got me interested, because they have different connections. They are operating at a different level than what all the other security technologies are doing.
Yeah.
And so from a market perspective, it's kind of like everybody's attention's over here, but you've got this really interesting place to play if you're an adversary.
Yeah, I remember. That begs the question, John, what's the relationship between the main hardware and operating system and the smaller subsystems that are essentially embedded systems within that hardware?
There's a lot of different relationships. And so that's where it gets really complicated. And this is, I think, part of why that space seems so obscure to people. If you look at, say, RAM, we think of RAM as this thing that makes the CPU work, but RAM itself has a set of configuration information that tells you how to use it. Same sort of thing if you're dealing with the, in the Intel case, it's the management engine, ME or AMT. In like an AMD, it'll be a PSP. You've got this whole separate out-of-band processor with its own memory and its own, file system dealing with all sorts of stuff. And those different interfaces are going to be sort of things that other people aren't using. And it naturally gravitates to this area where it's just not something you're thinking about. But I don't even think that's a bug, right? Like, that's a feature. If you think about the way that firmware is positioned, it's supposed to make your computer work. And when it's doing that, then you don't see it. You only see it when something's wrong.
Right.
Yeah, I remember when we built computers back in the day, because I built my own computers, and you think about BIOS settings, and then Windows brought in HAL and loading all the different modules. I mean, there's a lot of underlying pieces that start on a computer before the operating system really loads, right? And if you've never experienced BIOS settings and what does HAL do and all these other little pieces, you don't understand how the whole system comes together. We think at the OS layer, but there's pieces that rely. There's other pieces that are reliant,
like your video card.
Yeah,
and many of us as nerds have thought about this, right? But other people that aren't like technology nerds like we are see the computer booting up and don't realize that it's really the operating system on the graphics card that has to come up first. Otherwise, you wouldn't see anything until Windows loaded.
right? Because there's all kinds of stuff under the covers. Yes.
And the same thing with your storage. I mean, the list goes on and on and on.
You've got it. And I think that's the thing. It's back to this whole idea of, if it's working, you wouldn't know anything about it. But really, we see just the tip of the iceberg of what's really there. You've got a couple of BIOS settings that you probably think about. There's probably, 4 times as many that are hidden that you're just not seeing. All of those things are really just a fraction of what the hardware configuration settings actually allow. And that's where Eclipseium and really any hardware firmware security researcher is poking to find that next vulnerability. And that's where you're finding it in all of these different components. It's really a space where people aren't looking, and it's sort of not surprising as a result that there's a lot of stuff to find.
What I thought was interesting, and John, when you and I first met and you were walking me through this, was that once you boot up, when the computer's booting, these various subsystems are doing a lot of things to initialize the system. But once your operating system is running, that interaction between the operating system and these various subsystems or firmware is still there. And in a lot of cases, it's a two-way street. In other words, if I get on the operating system, it means I could potentially read and write to these subsystems. Is that correct? In what percentage of the cases you think?
I think it's pretty close to 100% of the cases. And I could give you some examples, right? We did a lot of research in system management mode, and system management mode exists for the purpose of actually having an interface between firmware and the operating system while it's running at runtime. And that's just one example. If you look at the firmware running on your network card, it's also obviously going to be doing its job while you're receiving network packets. And we can just keep going throughout all of these different devices. It turns out to become a problem where if you didn't have that interface, you're sort of locking yourself as a manufacturer of some different component into a really nasty spot, because if you need to reconfigure something later, you can't.
Yeah.
Does that make sense?
Yeah, it was like a F8 on the startup keyboard, right, on Windows, right, to get into that mode so you could see all the things that were loading as part of the whole
But back in the day, if I wanted to update my BIOS, right, which is obviously the most popular, sub-component of computers, right, because it needs the BIOS to be able to operate as a computer and ultimately load the operating system. But if you wanted to update that, I had to get my floppy disk, and I had to build a floppy disk, boot on my floppy disk, and it was a DOS operating system on the floppy disk that then could write to the BIOS, right? But today, we don't have that. When you update your drivers and firmware, whether it's Linux, Mac, or Mac maybe, but Windows especially, right? You load the utility. The utility can then write out new firmware to your subcomponents.
And in between there, we were doing USB as opposed to floppy disk, or you had to find a floppy and a USB floppy drive.
Mm-hmm.
But think about how all those things worked, right?
Yeah.
Those things were really just using the same hardware interfaces, and they were controlling the environment, right? You put it into a DOS environment because nothing else was going on. You might have used some special driver with some special environment so that if you did some crazy Windows thing, it didn't affect it. Maybe that was on your USB stick. A lot of these hardware interfaces are really just obscure. It's not that they aren't there all the time. It's just nobody really pays attention to them. They're not really being used. And what we're finding as people start poking at it is that they can really be used for really interesting, malicious things. So you can just imagine, maybe on your laptop or server, you've seen a ransomware attack. Well, how about a ransomware attack where you're not even going to be able to reinstall that thing because it's a brick? And that's the sort of idea that a firmware attack really brings to the table.
Yeah, we've abstracted away those pieces in the latest operating systems. Nobody ever sees those anymore. But in the early days of computing, we knew we had to play with that stuff, right? Mm-hmm. But now it's so abstracted away as part of how these OSs load. People really don't understand all those underlying components that are actually
Hold on, Lee
loading.
had a question.
So actually, I was doing a flashback to when you used to have a jumper on the motherboard to enable the BIOS update, which is so in the past. But my core question is, we've talked about traditional BIOS. Does the system on a chip modify that, make it worse, better, or just more the same?
It does modify that, but those interfaces usually remain there in some form or another, right? You can think of think of it like, there's a problem that I need to solve, BIOS updates. Well, I still got to solve that if it's a system on a chip. And so ARM has their way of handling that. AMD has their way of handling that. Intel has their way. And then all of the BIOS developers sort of then have their piece on top of it for how to do it. At the end of the day, whether it was controlled by the hardware manufacturer or maybe the firmware vendor, firmware developer, okay, but it's got to solve that problem at the end of the day. And so that's where now let's take it out of the BIOS, put that on the firmware that still boots, but sort of runs maybe a BMC on a server. And yeah, that might even be just a Linux operating system on another component that's kind of another computer in your computer. So it is going to solve the same problem.
John, when you analyze the firmware for these devices, obviously one tactic that we use for IoT devices is to spin up that firmware in an emulated environment. Do you have the similar capabilities for the subsystems within the computer, or are you relying more so on static analysis?
That's a great question. I am not sure that I would say that we can do any of those things 100% of the time, because if you think about it, every piece of hardware is going to have a slightly different set of specifics. But yes, we do use each of those different methods. We do have static analysis, and it's really useful for certain kinds of bugs, certain kinds of vulnerabilities, or heuristics, maybe I should say. Like, it turns out that you're going to have it's sort of weird if you're dropping Windows binaries on disk and you're supposed to be booting, configuring the hardware for the chipset. And that sort of a weirdness is the sort of thing that a static analysis can help you out with a lot. But then as far as a dynamic, more emulating thing, that's where we're going to find a lot of the bugs, like there's a buffer overflow in such and such module.
Right.
And we do that too, actually. So it's just, I would be careful just because saying that we can do any of those things on any particular case is a hard problem. Does that make sense?
Right.
I had a question.
Yeah, go ahead, O'Shea.
So from, I'm going to go selfish because I'm mostly on the defensive side. So from a blue teaming perspective, majority of the time when we're encountering malware or we're encountering suspicious executables or weird binaries, that's their objective typically is to land on disk and then inject it in memory somehow and then totally just live in memory and evade disk. So from an IR perspective, it's really hard to determine where it started, where it finished, where it came from. Which is really impressive what you've been saying, by the way. I'm going to have to look you up a lot after this. in a very nice way. In a very nice way.
Stalker!
But from a defensive perspective, like what advice would you give individuals like that are in my booth, that are kind of in blue team land, there's security analysts, incident responders, things along those lines of what we should look for? Because a lot of times we're leveraging different solutions, different EDR solutions to determine what's actually happening on disk before it hooks into memory.
Or 3, 4, or 5 different management systems that are trying to allow you to update that firmware, which you largely ignore because they're really crappy, because we've all been there.
Totally.
True, we do ignore.
I love that question because I like to think about, if I had a suspect system, what would I do? And when I'm looking at a particular edge case, I kind of have to make a call one way or another. Is this okay? And so this IR situation comes up a lot, actually. The first step, if you think about it, is actually just not to forget that firmware exists. And I know that sounds simplistic, but it actually is the first step because it's so easy to forget. And it's not just one piece of firmware. You could think about BIOS. Great. Okay, BIOS is a piece of firmware. And if you're not careful with the way that you're thinking about a system, you'll forget about it. So you might be doing a forensic image of the disk. That's cool. But if somebody persists something in the spy flash that boots the computer, you might not see it. Now, it's not because there's no tools for that. There are tools. I could help you find them. But the idea is you need to know to look for it. And then you can go through all the other components and say the same thing. Is that making sense as sort of like that?
Because to your question, right? I mean, if you think about how a lot of these EDRs do what they do is they hook into the kernel. And my guess is some of this you won't see at the kernel layer because it's sitting in a layer below the kernel, right?
BIOS and Flash. We're not going to, I guess, we likely would miss that. So
that's exactly it. No, I think that's actually what makes this space so interesting. It's what got me into the space in the first place. But now you can see that actual attackers are starting to take note of this.
John, that's where I was going. Can you walk us through a real world attack that I know you've observed where this has happened in the real world, just to kind of put things in perspective for ourselves and our audience?
So there's a couple of interesting ones, and I'll give you a quick overview of 3 of them. Right. 2 of them are interestingly and perhaps conspicuously in the energy sort of critical infrastructure sector,
which is frightening.
And yeah, right. And the third one is in this area of sort of maybe a nation state kind of stuff. But the interesting thing to remember as you look at all of these things is that the technique might have been a nation state technique 20 years ago. But if we talk a little bit more and you want to see a link to the GitHub repository that has all the same stuff that you can just go and implant on any laptop or server, if it doesn't have the right protections, it's going to work. And that's sort of the key thing that I see changing over the time that I've been in this space. I started out working for the government, looking at these things, thinking about a nation state adversary, but I then went to Intel and figured out how much of this we're seeing And then over the last couple of years, it's hard for anybody to have missed Meltdown Inspector and some of the other things. So back to your question, the first two on the energy sector, recently NERC put out a lessons learned report that actually talks about firewall firmware. And the firewall firmware had a denial of service sort of vulnerability that was remote. So you could actually bring down, and this is what they actually discovered, was somebody was bringing down visibility into some of the operational environment by DOSing the firewall. And so that was a firmware vulnerability, and this is sort of a firmware patch management problem, which is super hard. Like somebody said earlier, I don't remember who it was, but it was definitely this thing where people don't deal with that because actually it's hard and sometimes actually breaks stuff.
Yeah,
and if it's not broke, broke, don't fix it.
Well, and if it is broke, we call it a brick, not a computer.
Right.
Exactly. And so that's just one example. And so then there's another idea with the Black Energy 2 in the Ukraine power grid, and they brought down part of that grid with the intention of not making it real easy to bring it back up. Now, this is where firmware attacks are really a go-to place to break stuff, to brick things. And what they did is they actually corrupted the firmware on these serial Ethernet adapters so that now I can't go talk to the equipment anymore, and it's going to be super painful for me to go bring everything back on.
It was a brilliant attack. I mean, scary and one of the most evil attacks. But it essentially meant that if somehow your computer was surviving this attack and it was connected via Ethernet to the serial to Ethernet adapter, it means even if your computer was working, you couldn't flip the power back on because that's the controller that would allow you to flip that
You'd
power.
have to physically go find these things.
It was clearly a group that had a lot of operational knowledge about the environment, the types of devices that were there, had been there long enough to be able to determine the type of devices.
We call that group the Russian GRU.
Yeah. But also
at least that's the running.
The response time they had down too, because they had an idea of like it's going to take you this amount of time to go out to these specific.
But they made it worse,
switch.
John, because this is the very same attack where not only did they turn all the power off, corrupt the serial to Ethernet adapter firmware, they also turned the power off in the control room. So you were trying to deal with this problem in the dark, both in the control room and for the entire power grid.
You got it. And so this is where you can see sort of this nation state bit to it. But what makes this actually really scarier and in a way more interesting is the fact that that's sort of a thing that they did. There are tons of peripherals on your computer, and I don't care who you are or whether you're a nation state or whatever, that same sort of an attack is basically corruption of firmware. Now, you can try to protect against that in a lot of different ways, but with this many different components, how are you even going to know that there was a protection, what that protection was? Is it currently protecting me? We had another story. Before we started Eclipseium, we put out this open source project called ChipSec. And that just puts together a bunch of checks for a bunch of different hardware configurations, firmware configurations, things that are protections like this that may or may not be active. And one of the folks who was contributing to that project from outside of Intel went and gave a talk about an experience they had where they were, deployed ChipSec on a bunch of systems and started finding batches of them where what it was is there's a jumper on the motherboard, back to the earlier flashback, and one of these jumpers basically just disables the protections of the SPI flash where the BIOS is stored. And they were starting to find batches of these systems where that jumper was set such that the protection was completely turned off. And that's the sort of thing where, who's even looking at this? And that's the sort of thing where if there's a dozen or 3 dozen different components, okay, you got 1 or 2 of them right. There's a lot of probability that you got one of them wrong.
Yeah, I don't even think I can see the motherboard on this MacBook Air. I think it's so tightly. Who's even looking at the jumper settings on the motherboard, right?
Right, and that's the visibility gap. Whoa, that's the visibility gap that everybody has. If you look at if you look at what security software does these days, they're hooking API calls, they're hooking into the kernel, they're looking at files. Nobody really looks at the storage media for spy flash. Does that make sense?
Yeah.
Yeah.
So, John, what are some of the other, and you've got a great post on your site, The Anatomy of a Firmware Attack. What are some of the kind of attack scenarios that you walk people through? Because you do a great job of, I think, capturing probably all of the attack vectors.
I doubt it, but thank you.
Most of them, right?
we try to do that, and then we find 3 more next day. But that's the cool thing. Every component has a pile of vulnerabilities to it, because every one of them, just like you were saying earlier, it's its own little computer. It's got its own operating system, got its own libraries with its CVEs. It's actually a supply chain problem too, where you find a bug in one, and you're going to end up finding out that you didn't know this, but like 10 others used the same thing.
Yep.
And we did this with BMCs, for example. So we looked at some vulnerabilities, which ended up being in a component of the BMC that was reused in a bunch of other BMCs. And then we found, we disclosed this to one vendor, and now we found out a whole bunch more. And so that problem keeps coming back. If you look at
Joel's backdoor was the example that we talked about, right? Because once someone develops a very, very small web server and web application environment that runs inside of firmware on an IoT system, they're like, cool, we don't have to do that. We're just going to reuse it. It sounds like the same thing happened in BMC. Not only do they reuse it internally, they reuse it with their partners, and they resell it to other people, and it ends up spreading.
You got it. And the interesting thing is that sometimes it really isn't any different at all. You get these embedded web server type things like you're talking about, and you end up using them, and you use them for years, decades, because nobody knows it's there. If you look at one of the research posts that we put on our blog, maybe this is the one you were thinking of. We actually talk about these attacks as a remote attack vector. And the reason we do that is because most people don't get surprised by the idea that, 5 minutes of physical access is enough for me to open up your laptop and attach a programmer and we're good. Yeah. Not surprised. Maybe that's a little faster than you thought it was. But what's really shocking sometimes to folks is that you don't need any physical access. And that's where we actually remotely brick a server just with SSH to a command line. And what we're doing is we're using the BMC update interface to go install some interesting firmware to the BMC. And we go from there to go install some interesting firmware to the system firmware, the BIOS. And then at the command of, some kill switch when we feel like it, you can just have everything come crashing down. And your out-of-band management interface and your baseboard management controller, BMC, it's not going to help you anymore because it's hosed too.
Well, that's interesting, John. So when you get into one subsystem, say the network card or wherever, the storage system, there's little, if any, protections for me jumping from that subsystem to another hardware subsystem? Because of things like DMA, because it has to happen fast, there's no protection, correct?
You've got a great point there. And it's DMA is a good example. People are starting to introduce some protections on DMA, but it turns out that for a long time we didn't use them. So actually, it's probably not there on a lot of systems. But what you're really talking about is a generalization of what you might think of as the trust model within a single computer. And that trust model really hasn't been explored, and it certainly hasn't been tightened down. And that's what we're really showing and making visible at Eclipseium. And for me, that's the outcome of all these years of research into those different subsystems. Because why did we do the research? It's the same sort of problem that we're getting at, where it doesn't have any visibility. And now if you make it visible, there's a chance it might actually get better.
So John, when we think about security in an operating system environment, any organization, right? You've got to identify what assets are in your network. Then you do vulnerability scanning, detection, patching, et cetera, et cetera. But when we're at this level, inventory takes on a whole different meaning and concept, because it's not the operating system, it's not the asset anymore. It's like, what are all the subcomponents? Where are the vulnerabilities in the subcomponent? How do I patch the subcomponents?
John's laughing because that's what their solution does.
Yeah, that's like exactly how we describe what we do. Yes.
Yes.
I was gonna ask
so
how do you
here we go.
defend against
Here, I just teed you up.
Yeah.
Get ready to spike.
But now, John, if people want to
You wanna
learn
pitch
more
right now, because there you go.
Yeah, but I mean, so John and I have obviously talked in the past, and I think your solution's great. But if our listeners want to learn more, there's an email address that we,
Sure.
if you want to give that out and then
basic.
continue.
Absolutely. info@eclipseium.com. And so info, just regular old, any old domain, info@eclipseium.com. Eclipseium.com actually is also where you can go to find a lot of the anatomy of firmware attack that Paul was talking about earlier. We also have a threat report that we have people sign up for. This isn't just like a bunch of normal marketing. This is actually, we have a research team, and we are all a bunch of researchers as well. So we actually curate a list of what we find interesting happening in the firmware space. So if you were looking for it, eclypsium.com.
Yeah. So if you heard it on the show, send email to info@eclipseium.com. Tell me you heard it here. And Matt's question, I think, is very good, right? He does tee you up. You have all these different subsystems. How do you, one, know that you're vulnerable? And two, how do you manage updating all of these different systems that without a unified solution, you're on 2, 3, 4, 5 different solutions to get all this updated, correct?
You're right. And if you think about it, since each of those ones is made by a different manufacturer, you probably have a different updater for each one of them. And just finding out what you even need to go get is kind of a pain.
Yep.
Some of these manufacturers are doing a little bit better as we go, because they're Dell has their tool, HP has their tool.
Lenovo had some issues with their, and they've since gotten a lot better and tried to unify it even more, correct?
But China.
Right. So they're all sort of making progress. But let's say that you're an IT administrator for an enterprise, and you probably don't just use one of those.
Mm-hmm.
So this gets really fun for you really fast. And that's actually what we're trying to do, is by canvassing what's out there, collecting telemetry, and knowing how to poke at those interfaces, because that's what we do as researchers anyway, we are able to collect this sort of profile of what a device is supposed to look like. And now we can find deviations from from that profile as a security feature. But think of it now more like an asset tracker.
Yeah.
And the asset isn't just the laptop anymore. It isn't just the server. It's, you've got a dozen different things inside of it. It's your TPM, it's your RAM, it's your CPU. And you know what version of firmware each of those things is running.
Right. And that's what I loved when we talked, because that was my first question is, okay, so I put the Eclipseium software on my computer. It tells me first what I have in terms of various subsystems. It tells me if I'm behind and there's a vulnerability associated with them. But it also tells me if that, in a lot of cases, that firmware has drifted from what is known to be good from the manufacturer. In other words, I had a vulnerability, someone put a backdoor inside the firmware, and now you're telling me, hey, that doesn't match what's known good from the manufacturer. So it's really three things.
Wrong. Yep. You got it. And it's interesting, even from a vulnerability management, patch management perspective, because this area has been getting more and more attention over time, right? It's not the obscure, nation state thing that it used to be. If you look at just CVEs in the last 3 years, you're going to find that right now we're something like 7.5 times as many firmware CVEs as we had.
Jesus.
And now you're seeing industry analysts actually start to like make statements about this at Gartner, and F-Secure putting out a paper saying the third most common infection vector is actually firmware.
And
so
if
that's super surprising.
Yeah, and John, if we think about where the market's going in IoT devices, which are very heavily firmware based, I mean, the attack surface now is way bigger than just the MacBook sitting on my lap. It is now devices installed at homes, in plants, in corporations.
Independent of operating systems.
Yes, completely independent of an operating system. This is all firmware-based stuff.
And I think Lee's got a question in here somewhere.
Lee.
Yeah. So I've been wondering, John, you mentioned vulnerability disclosure, and you also had mentioned that the release time for patches is inconsistent. Have you seen any impact on fixing those vulnerabilities in your exposure with trying to explain to vendors where they have weaknesses, or has it been deaf ears?
I haven't really seen deaf ears. I've have in the past, but as we go, it actually does seem to be getting better. And maybe my position is a little biased because I did actually work at Intel doing the response to some of these things myself. But to be perfectly honest, a lot of it is mostly not knowing what you have. A lot of it is really the visibility gap. And that visibility gap isn't just true of you, the end user. It's actually often true even going back, and the manufacturer has to go figure out, oh, okay, this was not the current product. This was 2 generations back. Who was our supplier? Wait, I don't even know what they did. So what did they do again? And then they have to go figure it out. And I did this sort of things, and it is kind of painful no matter what position you're sitting in. So I definitely understand why we have, so much of a long lead time for say a firmware update versus, if you have your, 30th Adobe, vulnerability tomorrow, they'll crank it out today. But this is sort of a different game that you're playing. And this is actually why I don't think the same sort of solutions are going to work. You're not going to have your same Windows Update, Windows Defender, McAfee and Symantec and whatever. They can do some of these things, but the reality is that the whole market is in a different space. And so you could do both, but you're going to have to do twice the work. And so that's where Eclipseium kind of takes the specialty of looking at firmware, looking at hardware, understanding those interfaces, and tries to really focus in on that. And it's not to replace anybody else, it's really to complement it. Does that make sense?
But question now is kind of a multi-part question. Like, how first do we validate the firmware that's running on our components in terms of, like, that component has to basically boot an operating system, right? How do we apply a trusted platform there? And if that is available, how prevalent is it in the systems today to say, no, wait, the firmware you're trying to install on me is not valid, doesn't pass any kind of checks or cryptographic hashes, and then who enforces that? Is it the bootloader on the firmware? Is it the operating system? How does that work?
And to add on that, just one quick question. So if you think about it from a security operations perspective, when the majority of most organizations have a dedicated team to mostly like layer 3, layer 4, and layer 7 security, what should they be looking for if on top of those 3 questions that he just asked that we should be worried about? So when we see, let's say we do bring in Eclipseium, what should we look for and to think, okay, well, here's a potential backdoor that's been implemented inside of this piece of firmware. These are the next steps we need to take across the org, not just on this user's box or on this specific Ubuntu server or whatever it may be, but what do we need to do across the board?
Yeah, how do you operationalize that, right?
Yes.
Yeah.
That's a great question. So it's almost like taking that first question and then scaling it, right? Mm-hmm. You need to look at each of these different components, and you need to know, how is that component secured? How's it supposed to be secured, maybe I should say. And then you need to go look across the enterprise at all of these different systems and see, is that true here? Is that true here? Is that true here? This is kind of what we're doing. And so I'm going to sort of take the perspective of, this is how at Eclipseium we do it. I don't know, maybe there be some other ways, but there's obviously a reason why I think this is the right way. And the reason is that I don't want to have a single point of failure in this process. I don't want to put all my eggs in the basket of, okay, let's take an example, hardware root of trust. You can do a hardware root of trust. You can blow a bunch of fuses on some piece of hardware. You can say that that's some key that's going to check a bunch of stuff. Great. That's a very strong architecture. It's kind of good.
You could build it into
really
the BIOS.
right.
You could build it in the BIOS and say the BIOS is going to hold the keys that's going to validate all of the subsystems firmware, right? But that's still going back to your first point of that's a single point of failure.
Right, exactly. So like you can put it in the BIOS, you can put it in the hardware, and you can have the BIOS, the hardware checking the BIOS and the BIOS checking all these other things. And that actually is more or less what most people do for what they call secure boot. Now, what that means in a particular context, at the detailed level, it's different. But at a higher level, it's what you said. But the problem for me is that I've seen that so many times, whether it was some government system or some private sector, secure boot, boot guard, whatever, some Qualcomm thing, they all have at some point something goes wrong. And what are you going to do when that happens? And so from that IR perspective, from that operational perspective, what are you going to do when you find that really that trust anchor is actually broken?
You're going to disable secure boot, like what I do when I want to get into something working, right?
Check the box.
just like my Linux distribution, so I can get my wireless card to work. My AC 1900.
We've all been there. We've all been guilty of disabling secure boot.
Yep.
I agree.
Like I wanted to use.
We've all been
this
there.
Tool.
We've all been there. That's all I'm going to say about that one. But if you look at what the alternative is, you actually do have an alternative. You can look at what is the current state. What do I have? You can aggregate that data and get visibility on it. And that's the first step. If you think about what we're saying for an incident response scenario, we're saying the same thing from a risk management scenario. Get visibility first. That visibility is what lets you know, okay, what's the risk in my environment? This environment has some set of risks. Not surprised. That happens all the time. And then the next bit is going to be, well, maybe I want to know how to make it better. Maybe I'll deploy some patches. Maybe I'll do something, but maybe I can't. Maybe there's a reason I'm not going to deploy this patch. Maybe there's a reason that I can't touch that system. Maybe I can monitor that system instead and look for signs of anomalies or deviations. And that's what Eclipseium is actually doing, is all three of these. You enumerate what you have, and then you see from that what's vulnerable. And then you see, is there anything that I actually think I should really worry about? Because it's different. It's not acting the way it should. It doesn't have the same stuff that everything else has. Is that making sense? So it's sort of a
you need your own attack miter. That'd be awesome to have attack miter.
It is, but I mean, it should be part of.
It should, because they have Android, they have iOS, and then naturally they have normal attack vectors from a network. From a network and a web perspective. But the one thing they don't actually have that I haven't seen, and I follow attack miter pretty religiously, is something for firmware. Like that would be sick.
Just a couple. There's one about firmware persistence that I know of. There might be some more that I haven't quite dug up and found. But like one of our jobs is actually to go and kind of map these things to different areas. And that third real world attack that I was thinking about earlier is LoJax. LoJax was connected to the GRU as well, and you're looking at this as a persistence mechanism. Basically, it's doing the most brain dead thing that you would think of. The first time you try to do any sort of firmware attack, you're going to take all that operating system stuff that you used to do, and you're going to say, hey, I can just drop that again after you wipe the machine.
Right.
And yeah, that works. That's LoJax in a nutshell. If you want to defend against that, you actually have to look at firmware. So now you look at the firmware and you see, hey, wait a minute, I have an extra module in there. It's doing something weird. It's actually dropping stuff to disk. That's getting pretty interesting. And so that's what we're doing. We're sort of trying to take each of these three passes and try to build it in such a way that you don't have to go and build a bunch of firmware expertise, because that's what we like to do. So we're gonna try and do it for you and scale it in the way of just like, here's an installer, run some stuff, get back telemetry, and then we're gonna tell you that one, and that one. That's what's interesting.
Yeah, I mean,
was LoJax a UEFI attack?
It was. In fact, it's funny. well, for me, it's funny. It probably wasn't funny for some people. But the idea was when we released ChipSec, the very first release, the vulnerability that LoJax actually exploits in order to install itself into firmware was something that we deliberately added a check for in the very first release.
Interesting.
And it's super interesting that these folks actually exploited that vulnerability, because a lot of things, if you think before LoJax came out, there was a similar thing that did almost the same thing in the hacking team, sort of WikiLeaks stuff. And they also just took some Windows executable stuff and drop it to disk all the time. What was fascinating is that they didn't exploit any vulnerability. They just assumed that nobody had protected that machine. And that's actually a valid assumption on many machines, especially at that time. Things are getting better, but they're not getting better as fast as you'd like.
So do you think that the Russian GRU saw the release of ChipSec and implemented an exploit for that vulnerability you were checking for?
No, I don't. And the reason I don't is because if they had done that, they probably would have done it a lot more the way Hacking Team did. I'm pretty sure Hacking Team did see ChipSec because it's also in the dump.
Gotcha. Yeah. Okay.
So there's an interesting thing there where as research goes forward, things do get better. But things also include the attackers getting better as well. But for me, what I've observed is that the attackers have the incentive to go figure this stuff out anyway. The problem is on the defender's side. The defender has way too much to do, and we actually need to help them scale. We need to help them do things faster and easier and not have to go become an expert on some hardware interface.
Well, yeah, but that's why I'm a huge fan of open source, because if we go back to the Russian example, and I apologize, the author of Mimikatz, what's his name? Is a French. He seems like an awesome guy. I've watched some of his
Benjamin Delphi.
Yes, Benjamin has this crazy story, very similar to your release of ChipSec, right? Where he was developing Mimikatz and he was going to Russia to present it. And walked into his hotel room. Have you heard this story before? Right, he walks into his hotel room, and there's some Russian dude taking his hands off the keyboard as Benjamin's walking into his room. And then there's the shady character that comes up to him after his talk and is like, "Hey, can you thumb drive a copy of that to me?" And I respect Benjamin very much for his decision to say, you know what, at this point, I'm open sourcing everything that I have, because if the attackers are going to have it, the defenders are going to have it too. And John, I mean, that's essentially what we're talking about, right? By releasing ChipSec, if the attackers are going to have it, damn it, the defender should too, right? Everyone should have it.
You know, I didn't make that connection until you mentioned it, but you're right. And when you think about what I was trying to say about the sort of disproportionate incentives there, this is actually what you're talking about. It's the idea that an attacker is going to have this information, and they're going to be able to scale it, because that's kind of how this works. You find the attack, and now all of the things that are vulnerable to that are going to be doable to you as an attacker. Now, if I can make something available to the defender, they actually stand a chance. But if they if it's not available to them, this is going to go on for a long time, and it's going to work.
Yeah, and still NotPetya used Mimikatz and was wildly successful in certain environments.
Sure. And look at some of those where a lot of the initial infection vector is a vulnerability, and it's not a new one. No. It's an old vulnerability, right? That's another example where you can sort of say that. And if
is Conficker still running around on 08067? Is that Conficker?
Yeah,
right?
it is.
Conficker still running around
It's still
today.
out there.
Yeah.
Yes.
Yep.
And
not as bad as it used to be, but it's still out there.
Well, look at firmware now, and say the same thing, right? Look at how old the version of Linux in your BMC is. I mean, that's going to be the sort of thing you're dealing with. And now take your BMC, multiply times 8, 10 more, and those are the other components that also have similarly ancient libraries, just like those embedded systems that you're probably familiar with.
Yeah.
Probably still do too.
I mean, you could probably go to Shodan and still find stuff vulnerable to Joel's backdoor, which I feel like we should remind everyone that it was in your user agent string, it was Joel's backdoor spelled backwards, that if that was in your user agent string, you could log into D-Link routers of a specific firmware and gain unauthenticated remote access.
And you've seen that in other stuff too, right?
Yeah, and we see new ones like that all the time.
Yeah.
So
And that's largely the obscurity again. You know, it's not anything really hard. It's just that nobody's looking at it.
Right. Because it's at a layer below where people are.
Lee had a
looking.
question or comment in here.
Yeah, I just was wondering, sort of a side question, and pass if you want. Any experience with counterfeit hardware and detection?
So that's a related problem. I mean, experience-wise, there's some things that I probably can't go into, but the idea is that you're still going to look for something that's a deviation from a profile. Now, if you're the manufacturer and you're dealing with that, you might have put that thing there, right? That's cool. You have some knobs that other people don't have because you built it. But let's put it in the IT department's hands. You bought stuff the first time you see it. How do you know that you got the right thing? That's a huge problem for supply chain for a lot of enterprises. We are trying to solve that by building a profile for these devices. And you can actually see we're not the only ones thinking this sort of thing. You can look at open source. You can look at LVFS. ChipSec sort of started a movement there to start collecting some of that information. And now what we're doing at Eclipseium is really trying to just take that to the next level. Now we're going to support that at an enterprise level with an enterprise scale. And now the very first time that you get your machine, you run your Eclipseium scan, and it's going to tell you, hey, you have some different firmware that I've never seen before. Now, I don't know if it's bad, but it's different than everybody else.
Yeah, and you think about it in the context of not only counterfeit hardware, but stolen intellectual property components and other things, right? Because now you start to see those signatures and those behaviors elsewhere.
And this kind of segues into my next question. Stolen intellectual property going into counterfeits. How do we combat this on the mobile side? How do we, and I remember reading an article years ago that when you get a secondhand screen that doesn't come from Apple, comes from China, well, a different plant in China.
Or the same plant.
The same plant, just a knockoff screen, but that screen has modifications to its firmware. So how does this problem, John, extrapolate into mobile devices, and what are our defenses?
I think it's really the same problem. There are some gotchas with mobile devices, just like there are some gotchas with certain kinds of equipment that it's at the end of the day, it's some regular chipset and CPU, but you've put enough stuff around it that it's now an appliance and it's kind of different. Same idea on mobile, right? You have the same problems at the technical level, but getting to them and getting to that level of visibility is going to be harder because we've locked down the ability to look at those things. So if you look at the protections that the Android and iOS have on getting kernel level code to run, you're going to have a hard time installing some other third-party thing that's going to monitor that level. And yeah, that's a protection against an attack at that level. But again, you're putting all your eggs in that one basket where, okay, if something does break, if there is a vulnerability, that's what's going to allow this persistent, stealthy attack that you now can't see because no one can look at it. So that's a hard problem, actually.
Right.
I think,
Matt, you were making the point this week that, so what do I have to do? Have my MDM software jailbreak my phone so I can gain visibility to other things that might use the same vulnerability to not jailbreak, but also install malicious things.
Yeah.
That whole mess again, right? We've had that conversation before with lots of people, and lots of people are always, people come down on both sides of that. I personally am not a fan of leveraging an exploit in order to install the security software, but okay, you can do that if you want. But it does seem like it's a hard problem because unless you somehow create an attestation mechanism, something that gives me high confidence that I can see something and know the integrity of what's below me, you're going to be opening up a really interesting problem later when you find some vulnerability. Yeah. And so that's the hard part, right?
Does that also apply to, say, like ICS? Like, I haven't heard you kind of talk about a lot of the control area or ICS. You're talking about a lot of vendors and a lot of solutions or PLCs that are very highly customized and very well protected from the sense of a vendor intellectual property. So, like tearing into their firmware. Are you seeing a lot of the same issues and vulnerabilities associated with like consumer devices versus enterprise or ICS? And then are you having a harder time combating or finding security solutions to address those particular kind of vulnerabilities in that space?
That's actually an interesting segue. I find it very similar to the space that I was just talking about with mobile, where there are systems that maybe it's not a technical reason, like in some of these mobile devices, there's a technical reason why it's going to be a pain to try and get this kind of information out. But in some of these sort of OT environments, ICS, SCADA environments, that sort of thing is something you don't want to touch for a different reason. Pretty obvious different reason, but still, you're not going to want to go poking around at those systems, and that's why people don't do this. But to be fair, if you look at what other folks are doing in that space, they're also building a profile. They're also sort of looking at how is that device behaving? Is there any reason to believe that that device is different than all the others? And if you look at how those systems tend to be controlled, you probably have a regular computer somewhere. And that's the thing that you're remoting into. And that's the thing that's controlling and pushing out commands to all those PLCs.
Yeah,
So,
it's your HMI or your historian.
Your
right?
HMI,
Right.
for example.
Yeah.
So that thing is now it's a regular computer with all the same sort of problems that we've been talking about with CPUs and RAMs and TPMs and BMCs and all that. So that's actually where we sort of try to draw a line and say, we can scale this to most of the stuff. If we keep going past this line, we can do it. We're researchers, we'll figure it out. But it's more of a, if we do that, it'll work on that specific model of that specific thing. But this is going to be pretty scalable to most of the stuff in the enterprise. And so that's kind of where we prioritize.
Yeah, because that environment is
the Purdue level 3 and 4 and above, basically.
I suppose you could say that.
Well, I mean, if you're attacking ICS, you're going to be highly targeted anyhow, likely in nations. I mean,
you're going to go after a specific
the attacks
component.
we've seen, they've gone after specific components.
Right, that are going to have very dramatic impact to operations of a plant, a manufacturer,
and
et cetera.
it's multi-purpose operations too. So it's not one component that can only be shut down from one specific static perspective. It's like one component that has spiders into everything else. So like you can think about your motherboard or control. So if that gets shut down, what else do you do? Now your turbines are spinning.
Mm-hmm.
Right.
And you brought spiders into this. And
if they're spinning without steam in them, that's even better because now we have like infinite energy.
That is what that is the thinking that we brought into this as well, where we're really looking at, we can probably get 80% of what you're gonna need to look at, and this 80% is actually going to scale and be reusable versus the rest of it, where actually other people may well be better suited to go into that level of specificity.
Mm-hmm.
If you look at but the good news is actually, and there is some good news here, we are finding that a lot of these interfaces, a lot of these techniques are common. And it is right now a lot easier to go getting this visibility than it ever has been before. Mm-hmm. And so that's the whole point of why I'm doing this and why I kind of went into this space personally. But, I think a lot of other folks are seeing that.
But if you can give the GEs and the Siemens and the Belkins and the others visibility into their firmware to do a better job of protecting those devices, you don't necessarily have to do it, but it gives them the ability to actually look at it and understand those attack vectors and maybe do something about it.
And that's kind of the point, right? We're not talking about just any one organization or any one sort of segment or area. Yes, we target certain things that we think are going to be the ones that are most positioned to understand that this is the problem. But the reality is that these sort of firmware attacks are going to be the next big thing. If you look at where Just think about writing exploits. If you think about this from the 90s and you look at your buffer overflow with no stack protection and no heap protection and no randomization, okay, great. That's actually pretty easy. Firmware is in that space right now. There aren't a lot of mitigations. It's not complicated. So what you're going to find as an attacker is that pretty soon, if not already, the attack is easier at the firmware level. And it's easier because you don't have to do all this stuff and nobody's looking.
Yeah, there's no EDR sitting at the firmware.
Right.
Well, there is now. It's called Eclipseium.
Nice plug.
But I think there is going to be a shift towards of this style of attack, largely to maintain persistence, largely because a lot of the other remotely exploitable vulnerabilities are going away, largely going to rely on social engineering or other more creative ways of gaining an initial foothold onto the system, such as compromising the update of a popular accounting and finance software that is used in the country of that you're targeting in your attack, aka Ukraine, with NotPetya, right? I thought that was a really creative solution to spreading your malware. But what you're going to rely on once you get there to maintain persistence is these firmware style attacks, which largely they haven't really had to rely on to accomplish the mission. But as we get better as defenders, I think this is a logical progression.
And I think as the landscape changes, we're going to see more and more devices in all sorts of environments, whether it be enterprise, personal, you name it, that are relying on firmware,
right?
Of
And
some variety,
and not operating systems
that are on a quote single board, purpose-built computer, and what we used to refer to as a embedded device, embedded system. That this is going to be the next best thing. Like we talked about earlier, like Kubernetes, it's the future. Like no, this is the future.
I think so.
Yeah.
I think you can also look at this space as growing, right? Because there are more devices and there are more components within those devices now than there were before too.
Right.
Yeah.
So that just means that this area is exploding.
Yeah, and the proliferation of those devices is going to explode, continue to explode, both at home and in the corporate environment and everywhere else.
And when I just want to kind of chime in on that comment that Larry just made. This is the future. You talked about Kubernetes, but I think when you talk about the future and you talk about the security risks, the actual real thing that is concerning me the most is the fact that the control plane of everything is moving into software.
It's a great point, Jeff.
And that is something that we need to keep our eyes on, because it's really a serious concern because people don't separate that control plane from the data plane, and they just don't understand the ramifications.
And Joff, to your point, it's the software interacting with the firmware, and it's those two components that are driving how all these IoT devices work in the future. There's a software component and there's a firmware component.
But to Joff's point, we're moving more and more towards letting someone else have the responsibility and worry about security of the control plane that lives in the cloud, of the components that live within the devices that I'm using. And John's smiling, right? Because he knows this is a substantial amount of growth that we're seeing in an attack vector that could persist for quite some time.
Oh yeah, we're gonna have we're gonna have years of this. I can I'm not worried about working until I can no longer work. Let's put it that way.
No lack of job security.
Yeah.
Or unemployment.
There's work to do. I mean, another thing there. If you look at the if you look at the firmware as an example of that, you're finding the supply chain problem being not just I'm gonna go hijack the UPS truck and open the box and mess with your stuff, but you're finding that this vulnerable, broken, old component within something actually got propagated to so many other things. Now combine that with that control plane data plane problem that you were describing earlier, right? So now I can say I found something in some particular library, and that library now got reused on the control plane for some really interesting system.
Exactly.
Now you can go to town.
Now
right?
I'm not just ransomwaring one person's system or one company's system.
Millions.
If I ransomware the control plane, I got everyone who's riding on top of that. It's actually a story we have in the news about ransomware propagating to the cloud. The opportunity for attackers is that one ransomware attack can get a whole bunch of people at once.
And we did that actually with one of our research projects on bare metal cloud, right? We actually looked at the firmware, in this case of the baseboard management controller. And again, there was a vulnerability in this particular one, but now you have a multi-tenant cloud. And as you can update, and by update I mean infect, the components of the hardware that are being reused from one tenant to another, you now can infect another tenant. And that's just one example where, yes, that really is possible. And if you just go and look at, some of the examples you guys brought up earlier with IoT devices and Shodan, you're going to be able to find there's a whole lot more where that came from. We did the same thing with USB Anywhere, where we found this, control plane BMC component that was vulnerable. And look, how many of those are there on the internet?
And you can't use a DevOps process with a CI/CD pipeline and ephemeral software to update these firmware components.
No,
like it doesn't work.
You
to
don't
update
control
the environment you just described, you're going to take all your tenants down for a certain period of time potentially to update that firmware.
It's hard. You could try. I don't know.
Because infrastructure as a code is not dealing with firmware. It is spinning up something that's already available to me that you can reuse. You don't have control of that firmware in the cloud. In a lot, you
as
just
the customer don't. The cloud provider does.
The cloud provider does, but it's not a DevOps problem. DevOps is only looking at the CI/CD pipeline from a software perspective, but they're not looking at the firmware layer. They're just saying, "Hey, spin up this, spin up that, go."
Amazon, Microsoft, and Google have to have a process for updating that, and hopefully they've built enough infrastructure in the larger cloud providers to make that a seamless upgrade. But I find when you go to the smaller cloud providers, you often get emails like your site's going to be unavailable for this small window. Like this is like your card's up. Like push came to shove, we have to update something that we can't keep everything running when we do this update, right?
Okay.
Not when you're on a 99.5 cloud or whatever that SLA is going to be. But I mean,
larger providers may be able to ease that.
to shuffle stuff around.
You can shift an image, like
if
you can shift stuff to different.
Just tell me AWS is vulnerable so I can get some credits back. That would be sick. I would greatly appreciate it.
I'll work on that.
About $800 worth, right?
$600.
$600. Yeah.
But hey, you credit me your $600, and I'll tell you about the vulnerabilities that I found. No, we don't want to do that. That's not ethical. We don't.
Wink, wink.
Please answer the door when they knock, Paul.
Yes, exactly.
Right.
A lot of these big companies really can spend an enormous amount of money and time trying to solve this problem, and I would not be surprised if they're doing a pretty darn good job.
Agreed.
If you look at the research that they've put out, and I know how hard it is to be at a big company and put out public things, but hey, they did that, and that says something.
Yeah.
So I wouldn't go really saying not giving them credit, but at the same time, I would say that I know from experience how difficult this is and how many moving parts there are. So you can put a ton of work into this and still miss something.
Yeah.
And I think that's the really interesting part about visibility in this space.
Because Spectre and Meltdown
Yes.
to the cloud providers created some havoc.
Yeah.
And it created some impact to the operational environments that they're managing. This is just another example of the types of impacts that firmware attacks and vulnerabilities can have in a cloud provider that has to update literally millions of machines in their cloud environment.
Oh, yeah. And if you think about that, it's the tip of the iceberg again. You really are talking about, as bad as that was, just think how many more things have similar problems now.
Yeah.
So the question is given all this, how do we talk the CIO out from under the table in his safe room to objectively look about the path forward?
That's a good point. And it comes back to the same idea that, yes, this is scary. Yes, it's the tip of the iceberg. There's so much stuff there. But there is good news here, right? Like there is actually a point to all the research that we're doing and all the research that some of these other folks are doing. And the point is that it's actually a lot easier to get visibility now than it ever was before. And if you look at what you have to do in order to go put something out there and learn, what versions am I running? What do I even have? Is it vulnerable? We can actually put software at a regular software level with regular software deployment and get that telemetry back. And so you can actually do something about it today, where if you tried to do this before, I know because I've sort of worked with some of these groups that tried to do this before, you're going to be reading a lot of data sheets and you're going to get a ton of people spending a ton of time, hopefully making something that's stable enough to deploy. And so that's, I think, where we're headed, both as Eclipseium, but also really as an industry. Because as an industry, this problem is going to be replicated for every large manufacturer, for every large IT enterprise.
I think the conversation with the CISOs in it, you toe the line of the fear mongering, right?
You're right.
But if you look at ransomware attacks today, and some people deal with them okay, others are put out of business, and everywhere in between. But if you look at ones like, was it Maersk, the container shipping company? It was, which book was it that I was reading? I think it was Sandworm that did the first-hand account of, and interviewed, couldn't reveal their real names, but interviewed people who were on the front lines. Like, it was literally like an IT emergency like you could not fathom. I mean, they were literally running around, turning off network switches, unplugging machines to prevent NotPetya from destroying their systems, and it was almost to the point where they couldn't recover. I mean, the first-hand account, or second-hand, from the author, right, account of what happened really painted a picture for me of, wow, that's really scary. Then, John and I talk, and I'm like, wow, how bad would that have been if you're turning off as much infrastructure as you can so it doesn't spread? Now you're doing recovery, and you get to a certain point, it basically happens again because they're inside the firmware, right? And again, it's fear-mongering, but it's a legitimate concern to have these processes
because it's persistent
in place, right? To prevent that persistence, so that if we are recovering from a catastrophic attack, let's do everything to prevent it. Let's do everything to make our recovery easier. And by the way, we got to think about this piece that's in firmware, because if it persists there, we might as well just lock up and send everyone home, which, by the way, they actually did one day. They just they sent all their employees home because no one, either your machine was ransomware, and not even ransomware, it was basically destroyed. There was no decryption key. It was destroyed, and they basically, your other systems were turned off, so they sent people home. That's a bad day, to say the least.
That's a bad day.
Well, I mean, it's a good day if you get to go home, but
well,
But also
it's a bad day for the business.
It's a horrible day for the responders, because you have to think about how many images of memory and how many disk images you actually need to start to correlate and actually dig through.
But this is the story where they had to fly to, was it South Africa or?
No.
Where did they fly? They flew the one copy of their Active Directory.
It was like an E.
They met in Egypt. I think they met in Egypt. They flew someone from the UK to Egypt, and someone, I believe it was South Africa, had that one copy of the Active Directory that magically didn't get ransomware, and they flew in, I think, Egypt to meet to make the handoff. But can you imagine the person carrying the hard drive that is the future of your company? Like, if you lose that hard drive, or it's corrupted, or you drop it, or whatever,
game over.
Your company no longer exists.
Send all the security to this dude. Like give
one
him
dude's
everybody. Give him all the security we have.
You're the person.
The exchange was a briefcase with a hard drive and a briefcase with like a ton of cash. Thank you.
Or actually no cash, because he was an employee. So it's like, actually,
hey man, you got the stuff.
It's like, you just saved us $2,000.
But you can imagine
Thank
the
you for doing your
stress.
job.
You're traveling on an airplane with anyway. John, we just have 5 questions left for you in a game that we call 5 Questions with Security Weekly. Are you ready to play Security Weekly 5 Questions?
Sounds good.
3 words to describe yourself.
I am John.
Oh, wait, it wasn't O'Shea's answer. Damn it.
If you were a serial killer, what would be your weapon of choice?
Firmware.
If you wrote a book about yourself, what would the title be?
That's good enough.
Okay, yeah, let's do that.
In the popular game of Fast Grabby Grabby, do you prefer to go first or second?
Second.
Choose 2 celebrities to be your parents.
Joff?
Alive, dead, fictional, or otherwise.
Ooh. Interesting. I think Mark Hamill would have to be in there.
Oh, that's a good one.
Man, that is a good one. Yeah.
And let's see. What would be good?
What would you say? Luke, you are my father.
Yeah. And then let's go with let's
It's on the tip of your tongue.
Starts with an A.
What's this?
Oh, I don't know.
She was married to Brad.
Oh, actually.
That's the single most popular answer we get for the
really?
For whatever
Really?
reason.
for the mob.
I think it was her role in Hackers, really. Yeah.
Actually, that's a great idea. There we go. Let's go with that.
Angelina Jolie. There you go. John, thank you.
Remind me of the movie.
If folks are interested, info@eclipseium.com. Send them email. It has my seal of approval. And as you heard from all the details, in this segment, it's something you should be paying attention to. So, John, thank you so much for appearing on Pulse Security Weekly.
Sounds good. See you guys at RSA.
Absolutely. With that, we'll take a short break. Come back with the security news for this week. Stay tuned.